Welcome. This video is going to talk a little bit about how we name covalently bonded substances. Covalently bonded substances are called molecules. So a molecule that only contains two kinds of elements are known as binary molecules, just like we have binary ionic compounds. With binary molecules, both elements are going to be nonmetals since electrons need to be shared, so no one's trying to lose electrons. So it's not going to contain any ions or metals because metals always lose electrons and form positive ions. So that would be an ionic compound, but we're talking about just molecules, just covalently bonded things, so just nonmetals here. And to name our binary molecular compounds, you use the entire name of the first element in the formula, just like we did with ionic compounds. We change the name of the second element to an IDE ending, just like we did with the ionic compounds. But now, because we don't use oxidation numbers to determine the ratio of this, we have to use prefixes to tell the chemist or whoever is using this formula how many of each kind of atom is in the formula. And the prefixes are pretty standard. One is mono, two is di instead of bi, but di, not too difficult, diatomic, two atoms. Three is tri, four is tetra. A lot of people want to use quad, but think of tetras, it's tetra. And then five is penta, hexa, hepta, so just like you're used to in math. So the only exception is you don't need to use the mono for the first element because so many covalent compounds have just one first element, one single atom at the beginning. So we'll take a look at a couple examples here. It says, name the following binary molecular compounds. So if I have pH3, I write the name of the first substance, which is phosphorus. Let's see if I can spell phosphorus here. And then I write the name of the second compound, changing it to IDE, so this would be hydride. And then I put the prefix in front to show how many of each. I don't need the mono in front of phosphorus, but it'd be phosphorus trihydride. I could have left a little more space between my two words because this is two different names. You split apart the first element and the second element. So looking at my second one, I have silicon is my first element. Hydrogen again is my second element, so this again would be hydride. And now I have four of them, so my prefix is tetra. And you just write it all as one word. You don't need a hyphen or anything, just tetrahydride. And then my last one, I start out with hydrogen. So this time I don't change it to hydride because it's the first element. The oxygen does get changed to oxide. And now I need a prefix on the first one because there's two, so this becomes dihydrogen. And my oxygen becomes monoxide, or instead of writing the double O, it's usually just written monoxide. So water's chemical name is actually dihydrogen monoxide. So then there's a special group of covalently bonded molecules. Some of them are binary and some of them are not. But acids is a special group, or are a special group of covalently bonded molecules that usually contain hydrogen bonded to a nonmetal or a polyatomic group. And the hydrogen is often the first element given in the formula. That's one way you can recognize acids quite often. So things like HCl, HNO3, H2SO4. Now, of course, H2O water is the exception. Hydrogen's at the beginning, and we don't think of water as an acid because it's not. And two types of acids are binary acids, which contain hydrogen and then just one other nonmetal element, or oxyacids, which is hydrogen bonded to a polyatomic group. And it happens to be a polyatomic group with oxygen in it. And if you look at your polyatomic chart, most polyatomic groups do have oxygen in them. So how do we name these? Well, we name these a little bit different so you know they're acids. In fact, the word acid is always the end of their name. So with the binary acid, if it's just hydrogen with one other element, then you start the name with hydro, followed by the element's name changed to an IC ending, and add the acid to the end. So for example, H2S, it's hydrogen with just sulfur, so this would become hydrosulfuric acid. H3P would become hydrophosphoric acid. With an oxyacid, it's a little bit different. Now you find the polyatomic ion's name. If it ends in ATE, then you change its name to ic, and it just becomes ic acid with no hydro in the front, because hydro would mean there's just two elements. If it ends in ITE, you change the polyatomic ion's name to us. So let's say if it was sulfite, it becomes sulfurous acid. And I see I'm missing a D here. Or HiO3, if you look that up, that's iodate. So I would change that to ic, and it becomes iotic acid. Squeeze a little D in there for you. So here's some examples for you to try. So you might want to pause this before you watch me write in my solutions. HCl, I see, has got just two elements in it, just one nonmetal there. So this is going to be hydro, and my chlorine is going to change to chloric acid. And with my second one, again, it's just one nonmetal attached to it. So this is going to become hydro nitric acid. No prefixes used with the acids. HNO3, this is a polyatomic ion group called nitrate. So I had a student one time tell me that they remember 8 is ick because I ate it and it was icky. So nitrate becomes nitric acid. Now you can see I don't want the hydro in front because I've already used that name. These are not the same thing. Okay, not the same acid, even though they look very similar. And then the SO4 is sulfate, so this would be sulfuric acid. Now the good news is you don't have to commit these to memory. A chart on your helping hand to help you out with this, and in fact I've given you an example of that on this next slide. So here's another try it for you. This one goes back to naming binary compounds and giving you some practice. I want you to actually draw the Lewis structure first, see if you remember how to do that, and then see if you can come up with the name for these. So again, you might want to pause and try this on your own, and I'll go ahead and put in my solution as well. So with OCl2, when I take a look at that, I see that oxygen needs 2 bonds. Each chlorine needs 1 bond. So oxygen has its 6 valence electrons, single bond each looking for a bond. Chlorine has 3 lone pair and 1 looking for a bond. So that's what I would expect this structure to look like, and I would name it oxygen dichloride. My second one, GE, is in the carbon family, so GE is looking to form 4 bonds. Each oxygen is looking to form 2 bonds. So hopefully you can see that this is going to end up being GE double bonded to oxygen. That still leaves 2 lone pair on the oxygen, but the GE has got 4 shared pairs, or bonding pairs, so it's good. And this would become germanium dioxide. And hopefully you're getting an idea why we don't use mono in front of the first name, because so many things would be mono. It's a flow chart that I think is helpful for deciding how to write the formula. First thing you want to look at and see is, does the formula start with hydrogen? If yes, it's an acid at least 99% of the time. If no, it's a binary compound, so you just name the first element, name the second element with an IDE ending, and add the prefixes. If it's an acid, you have to decide if it has oxygen or not. If it doesn't have oxygen, it's binary, and you just use hydro with the element's name changed to IC acid, like hydrochloric acid. If it's got oxygen in it, then it's going to have some kind of polyatomic ion in its formula. And you look and see, was it like sulfate and becomes sulfuric acid, or was it sulfite and becomes sulfurous acid?